Okay, so 5 and 7 are vertical angles given. Alright? Not everybody at once, please raise your hands. What do you see up there? Or what can you talk about up there? Yeah? But something that we've used over and over again, or what else can you identify from that picture? Okay, you're in the right. We're trying to classify, not complementary. Yeah, it's an all-arounded. So let's start here. It's a good place to start. I'm asking you guys to use a geometric term to identify something you see in the picture. We tossed around the word complementary. Yeah, that's good, but it doesn't really apply here. Acute is good. It kind of applies here, but only to angle 5 and 6. Or only angle 5 and 7, not necessarily angle 6. What that thing is called?
The construct thing, maybe.
So what do you call a pair of adjacent angles that form a line? Huh? No. A pair of angles that form a line. A linear pair. So say that geometrically.
Angle 5 and angle 7 are a linear pair.
No, sorry. Angle 5 and angle 7 are vertical angles. See that right here? Angle 5 and angle 7 are a linear pair.
I'm so confused now.
What?
Isn't that
Isn't that what Rafe said?
Huh?
I thought that was
Oh,
what Rafe
sorry.
said.
Oh.
Rafe confused me. Angle 5 and angle 6 are a linear pair.
Definition of a linear pair.
Why are they a linear pair?
Because it's the definition.
Because that's the definition of a linear pair.
No, you didn't.
I think I don't understand.
I caught myself though. Aha.
What do you know number 3?
Angle 5 plus angle 6 equals 180.
Are we supposed to prove that we're like kind of
Yeah. Okay, no, I like where you're going with that.
It's like, what?
Okay, that's where I want to go next. If I said 5 and 6 are a linear pair, shouldn't I also say that 6 and 7 are a linear pair?
Yeah.
So instead of writing a whole new statement, I'm just going to put comma, angle 6 and angle 7 are a linear pair. And it becomes the same justification. So statement 2, I'm saying 5 and 6 are a linear pair. And 6 and 7 are a linear pair. Why? Because of the definition of a linear pair. Have I lost anybody yet?
Yes.
I did. So all I did was look at the picture and use math to describe the picture. Do you understand that 5 and 6 are a linear pair?
Yeah.
Perfect. But do you know why we put that?
Like I get it, but there's so many other things that's like why we put.
Because I know the end game and you guys don't. So there's a purpose for justifying, for stating that these two are a linear pair.
What if we do that and 6 is the same angle, and if 6 and 7 and 6 and 5 are making that linear pair, then 5 and 7
So-
are the same.
The definition of a linear pair says something very, very, very specific. Two angles that add up to 180 degrees. So would it you have to say that they're a linear pair. You have to state that in order to state that. Why would you say they're a linear pair? Because it gives you the ability to state something else.
Angle 5 plus angle 7.
Not angle 5 and angle 7.
Oh, angle 5. 6.
angle 5 and angle 6. The measure of angle 5 plus the measure of angle 6 equals 180 degrees. If that's true, then what else should be true? Comma, the measure of angle 6 plus the measure of angle 7 equal 180 degrees.
Would that be the angle addition question? Oh, no, wait.
Think about it.
Well, if, couldn't you just,
Would that be transitive?
oh, I don't see.
Addition. Let's just say all things.
Yeah, would that be transitive?
So transitive property would say if A happened, then B happened. If B happened, then C happened.
Okay, that's.
Angle 5
Okay, but
Complementary.
I'm still looking for a reason why 5 and 6 add up to 180.
Definition of
Supplementary.
Because supplementary angles add up to 180 degrees. I
So
want
just
to make
put
sure
definition of supplementary angles.
they write it weird in here. I want to make sure I give you the same weird way they write it. Because we understand what we're saying. And I always go back and second guess myself on this. Yeah, so the definition of supplementary angles. Now what can you say? Go ahead.
the measure of angle 5 plus the measure of angle 6 is equal to the measure of angle 6 plus the measure of angle 7.
Good job. I know. So.
What?
Substitution.
No.
I know it. Wait, let me answer.
Huh? Angle addition.
No, hold on.
Transitive property. Yeah.
Transitive.
Wow.
Excuse me?
The transitive property of angle equality. So that's a really, really weird one because it kind of goes like this. 5 and 6 equal 180 and 180 equals 6 and 7. So you can connect those two statements. If A equals B and B equals C, then A equals C. Huh? I'm deleting this repeated part. Now I know some of you guys are super upset about that because I told you guys that it had to be written in order. Now, the book does this. I'm not a huge fan of it. Now, if you didn't like this, where you wrap it around like that, then you'd have to write this statement again, but flip it. 180 equals the measure of angle 6 plus the measure of angle 7. Then you have to justify flipping that statement by writing the symmetric property of angle equality. Then you could write the transitive property. Does that make sense? So this does work. It's not great, but it works. It saves you some steps. Yes, sir.
Subtract the measure of angle 6 from the 6.
So your next statement would be the measure of angle 5 equals the measure of angle 6, or the measure of angle 5 equals the measure of angle 7 because you took away the measure of angle 6 from both sides.
Angle subtraction of measure of angle
just call it the subtraction property.
Would you have to put of an angle?
Of equality. Okay, now what? Make it congruent. I'm not gonna find it in there. So how are we able to switch from equality to congruence?
Definition of
The definition of congruence.
Yeah.
Because if they're congruent, they are the same. If they are the same, they are congruent. Math happened.
It's been like,
Wow.
What's that? Can you put definition of equality?
What is the
So the book says angles with the same measure are congruent. So it's I got a 6 to 1, half dozen in the other. Now, oh, throat noise.
It's pretty easy.
you're kidding.
So
I wouldn't
let's,
say it was easy.
there is a purpose for this. So we say 5 and 7 are vertical angles, that's given to us. Now we have to get some sort of geometric definition that connects 5 and 6 together. Now 5 and 6 are a linear pair. It says 5 and 6 are a linear pair, or we could say 5 and 6 are supplementary. Either way, the definition of a linear pair. So the same thing. Now we're tying. We put this linear pair word here so we could draw that 180 conclusion from that. So now that we have an ability to draw that 180 conclusion, we can write it. 5 and 6 equal 180. 6 and 7 equal 180. The reason it's true is because that's the definition of supplementary angles. If you add two angles together and they equal 180, they're supplementary. So now that we have an algebraic statement here, we can start combining these two statements together. 5 and 6 equal 6 and 7. And we have to use the transitive property to make that happen. Then we get to algebra, subtract the angle 6 from both sides, 5 and 7 are equal, and then we finally get to the congruence part. Yes?
On the test, you have to like write your own, or are they all like
For now, they're fill in the blank. For later, you have to write all of it. Okay? Now here's something that really great that happened. Whereas what have we just proved?
That angle 5 is congruent to angle 7.
We have just proved
Angle 5 is equal to angle 7.
I just said that, right?
and I didn't tell her yes, you're right. She wasn't right. Use math words. What did we just prove?
The measure of angle 5 plus is equal to the measure of angle 7.
No.
Congruent.
I
I don't know.
How is
What's
that
the
vertical
vertical
angles are congruent?
We just proved
They're vertical
the
angles.
vertical angles are congruent. Now, watch this. Yeah, watch.
Ayúdeme. I'm so just.
Now it's a two-step proof.
Given.
Now it is.
You can just do that.
Now we can.
Vertical angles are congruent.
You get on the test. Use it on the test.
Please tell me we can do that.
The vertical angle theorem. So if something is not true until we prove it's true, right? The angle addition postulate, you accept it as true. We just proved no matter what, doesn't matter what the angle is, what it looks like, if they're vertical angles, they are congruent. So we went through all that math for a reason. Okay? Now, if I ever give you a problem that says angle 5 and angle 7, can you say that they're congruent? Can you say angle 5 and angle 7 are congruent now? Yes, and what is the reason angle 5 and angle 7 are congruent now? The vertical angle theorem. Right? So you don't have to go through a 7-step process to prove 5 and 7 are congruent on a test. You can say the vertical angle theorem. Does that make sense? That's the reason we do this stuff in class. We just justified everything. Now, if you got that or didn't get it, what should you gain from this conversation? Math. You should know that vertical angles are congruent. Why? Vertical angle theorem. That's what you should gain from this. Now let's look at the next one. Oh, dear baby, look at that. It's already almost all the way done for you. Would you like there for there to be more? Let's just knock it out. It says given AB equals 5 and BC equals 6. Given. And it tells you that AC equals AB plus BC. Why is that true? AC equals 5 plus 6. How can we do that?
Substitution. Oh, wow.
Question mark?
AC equals 11.
The measurement of line segment AC equals 11. Why? Simplify. Realize where you were on Friday and where you are right now. You're like, this is cakewalk right now. This is kind of what your test looks like.
Really?
No. I'll give you the option. You want to do the right angle or the straight line? This one? Alright. Remember, you have to state it before you can use it. Okay? So, the first part of a 2-column proof. Make 2 columns. First step. What? Why is no? There are 2 givens.
1 and 2 angle.
So then when you just put a comma after the
Comma.
Oh, we should wait to do measurements.
Did you say comma?
I don't know.
Yeah.
Oh!
That's what I said.
Okay.
So if those are given, this is why we number our steps. Can you put statement 1, 1 and 2 are complementary. Statement 2, the measure of angle 2 is 74 degrees.
Yes.
Yes, but then you have 2 given statements. So you can lump them together or you can separate them. It does not matter to you. On your test, when there are multiple given statements, in order for your proofs to fit, I will tell you, you need to put 2 given statements or you need to put 1 statement for given. I'll kind of key you into that. Awesome. Now what?
Measure of angle 1 plus measure of angle 2 is equal to 90 degrees.
Okay. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. Why is that true?
Definition of a complementary angle.
Definition of complementary angle. The definition of complementary angles. So now you're saying, I know that complementary angles add up to 90 degrees. I should probably write that down. Go ahead, Kate.
Oh, for number 3?
Sure.
The measure of angle 1 plus 74 degrees equals 90 degrees.
Would that be substitution?
That is substitution.
Wait, wouldn't you have to put like an angle?
No, it's just substitution.
Measure of angle 1 is equal to 60 degrees. Subtraction.
subtraction
From an angle.
property of equality. So the transitive property, the symmetric property, and the reflexive property have to be like a property of angle congruence, property of segment congruence, property of angle equality, property of segment equality. You tell me what you're doing there. Generally, if you put symmetric there, I like, hooray, you got it, and I'll kind of move on from there. I'm just trying to make sure you guys know what it is. So if you put transitive property, be like, check, you're right, okay? I'm not going to count it wrong if you put the symmetric property of equality when it's congruent.
Which ones are those? Subtraction, transitive.
That was the symmetric, reflexive, and transitive. So that was the notes I gave you guys on Friday that had like segment equality, angle equality, and then segment congruence and angle congruence. They are important, but in our infancy steps, I'm not that worried about it. And then we're done, right? Hooray! That wasn't that bad. So let's just talk about this, and we're not going to write it down. We're just going to develop. This is called developing a proof, where you just verbalize it. What do you think is going to happen here? Your question?
No, I said great question.
So just talk about it. What do you see? What do you know?
Our first step can be the two givens, so
Okay, step one, line x, y, w, and measure of angle x, w, x, z is 135 given. Perfect.
it's a lot harder thinking about it.
Measure.
It's not really
Yeah.
It's a lot harder when it's not written down.
What did you say the next one was?
Plus the measure of x, y.
I think I saw that.
Definition of supplementary.
Okay, now I have to stop you there. How do you know that these two angles add up to 180? So technically it is given. It says line x, y, w.
WXY.
Line w,
Oh,
x, y.
because it's you're proving one.
Now, how did you jump from here to here?
As a line.
But did you say that?
Oh,
You
definition.
have to say that. You have to say that line x or w x y equals 180 degrees. Why? Definition of a line. Now, that's kind of weird. I know you know a line is 180, but it's the person doing this know that that's 180. So you have to tell them, hey, a line is 180. Now that you have this magical 180 number on the board, you can say that the first angle and the second angle equal 180 degrees. And is that the definition of supplementary angles?
Yes.
Yes, but we don't know that they're supplementary until you know that this line is 180 degrees. Or you could have changed that and said this one plus this one equals 180 because of the angle addition postulate. Either way, supplementary angles add up to 180. The angle addition postulate says that they're 180. And then everything else, yes. We're gonna go to the next step?
Yes.
Yeah.
What is it?
For 135.
Oh.
No.
Wait.
The measure, I was gonna say 135 plus the measure of angle z, x, y equals 180.
Yes. So 135 plus the measure of angle z, x, y equals 180 in that substitution. And then you would subtract
So the measure of angle ZXY is equal to 45 degrees.
subtraction property. So I guess this is only the really nitpicky step. When we get to the proofs, when we do this stuff, I'll give you guys a really good way to check to make sure that you're stating everything, right? So over here in this column, I'll put over here like, do you have an H? Do you have an L? Do you have an A? Do you have an S? That way you can actually prove what's going on. So you should have a statement here that's verifying each thing. This is as close as I can get it as for your test right here. On your test, the reasons and statements bounce back and forth. It should be in your notes, right? Yeah. So we're just going to fill in the blank. Why is AC equal to 13 and BC equal to 3?
Given.
Now, it's not written here, but it is provided here, so that is a given statement.
Addition.
But what are they adding together?
Oh,
It's
that
addition postulate.
So when you say addition postulate, you're right, but there is angles and there are segments. So you have to be specific. Now we get substitution. Take the geometry out and put the algebra in.
Subtractive property. Given.
Are you sure?
Yes.
Way up here. And you wrote it in the middle. That's fine. Get it.
Transitive?
Huh?
Transitive?
Substitution. I have no clue.
Definition of congruency.
Definition of congruence. If things are congruent, they are justified to be equal as well. Definition of congruence says if they're congruent, they are equal. If they are equal, they are congruent.
Oh, substitution. Oh.
Question mark? Are you guessing now or are you actually doing it? So realize that it says that AB is 10 right here, and now they're changing it to FG is 10. But right here it says that AB and FG are
Oh,
the same.
transitive.
Transitive.
Substitution. It is substitution. I'm just trying to point out for people who don't see it. AB is 10, AB equals FG, so we can substitute that in. It says EG is 13, and we wrote that AC is 13, and AC and EG are the same, so we can substitute that in. That's kind of like go hide and seek for math here. That is substitution. Again, that is the segment addition postulate. Substitution again. Subtraction. Simplify is when it happens on one side of the equal sign. Subtraction when it goes across both sides. Yeah. A lot of different steps there. Okay, I'm gonna hand you guys two things. One of these is practice with proofs. Okay, I'm gonna pick this up tomorrow. We'll probably cover some of these tomorrow in class. And then the other one I'm gonna talk about is is the review. So the test is on Wednesday, but I'm giving the review right now. So that way you guys can have a lot of time to practice it. It's just one page. It's significantly shorter than the last one. Now, I always do this. Let me hand this stuff out. So if you look at your assignment,
This doesn't look like.
what is the first thing that we did in class today? Proved what? Vertical angles are congruent. Are those vertical angles?
Absolutely.
They are congruent. I'm asking you guys to make the jump that says 3x minus 40 equals 2x minus 10 because we just proved that in class today. Vertical angles are congruent. If so facto, they are equal to each other. And then you solve for the value of x. What do you mean, what? Minus 2x on both sides?
So that was subtraction.
No, you're just mathing. You just math it, guys. It's a problem. Go back to just basic
You
math.
don't want us to write this over?
No, I want you to solve for x. X minus 40 equals negative 10. Add 40 to both sides. X equals 30.
Yeah.
Hooray! You should be able to plug that back in and check your math. 90 minus 40 is 50. 60 minus 10 is 50. Verified. X equals 30 and the angles are 50 degrees each. So we used a proof to verify a theorem, and now that you know a theorem exists, you should be able to apply that theorem. So down there on number 10 is where it gets into your first actual proof thing.
Wow.
That's where you have to fill in the blanks. You'll notice that one of the reasons is vertical angles are congruent. It tells you that is a reason you know that's true. On the back are some other ones. Guys, number 11, I cannot stress how important number 11 is because that looks like the proof on your test. So if you're a guy that does homework in here, if you're a girl that does homework in here, I would spend some time and make sure you know how to do number 11. Just throwing that out there. That is verbatim, almost exactly the one that's on your test. And then number 12 and 13 are those hard ones where you have to write out in words what the proof is going to do and not actually do the proof. Okay. I'm going to hand you guys the review today as well.
When is
The
that
review
test?
should be worth extra points. I'm not sure how that's going to be applied yet, whether it's 5 points or it's a root curve. Let's do that.